Good morning and afternoon, everybody. Welcome back to our weekly Autodesk HSM technical webinar. This is our Kickstart series on to help you kickstart your CNC programming. Those of you who have recently downloaded our easy-to-use and completely integrated CAM solution for SolidWorks, which is HSM Works, Inventor HSM, or Fusion 360. So today, we're going to talk about 2D milling or 3D milling, maybe a little bit of both. And last week we talked about the basic principles of turning inside of Inventor HSM. This week we're going to stick with Inventor as well, looking in the milling side, but we're going to do a little bit more. Over the past few webinars, a few of our attendees have asked questions on how do we get those fixtures into Inventor to use and set up. Some of our orange fixtures, chick vices and Kurt vices. So today I'm going to show you how to do that. I'm going to walk through how to go into a website, download a Kurt vice. We're going to download and convert the model using any CAD in Inventor. How to work with that assembly. When you download it, becomes a solid body, and we're going to convert that to in Inventor to be able to use multiple components to make it a fixture assembly with a moving jaw so you can put a part in. And that's the next step, is we're going to show you how to put a part into that assembly and use it as a template. So it's a really good idea to make an assembly that matches what you have on your machine. This way you can be much more accurate with your code. You don't have to apply that setup over and over and over again. And then we're going to apply some 2D and 3D toolpaths after we set up that part in the assembly. And then we're going to output some code. We'll get some code that we can run in the machine. And then we'll make some design changes to the part and show you how quickly it updates, how easy it is to get that update done, and how complete our integration is on the CAD and CAM side. So just to show you, this is the vice. We're going to download that vice, bring it in through AnyCAD into Inventor, and then we're going to apply a part, put the part in there, we'll put some toolpaths in there, get some code, update the part, and then show you how that integration works. Okay, let's jump right in and get started. So let me, I'm going to open up my browser, fresh browser. Looks like we're getting ready for Christmas soon. So I'm going to take a look for our Kurt vice. I'm going to look for a Kurt D810. It looks like I've searched for it before, but I'm going to do another search. And you can do this as well. So I'm going to search for Kurt. It looks like we found the Kurt work holding website. So I'm going to click and go into the website. And it even looks like our vice on the machine. So I'm going to scroll down to the bottom, and many of our fixture and work holding companies would allow us to have an area on the web where we can download some of their models. Looks like it requires another update for being able to preview the files, but we have lots of different types of files we can download. Looks like we even have Inventor, which is output as an SAT file. You can download that. Any of these files will work if you download them and bring them into your Inventor. I'm going to bring down this SolidWorks file because I'd like to show you that conversion. Right now I'm going to work with 2016, and I'm going to download that file. So I click download, it opens up and says, now here's a file that you're able to download locally. I click it, it goes into my downloads folder, so I can open up that downloads folder. Oh, looks like it tried to open the part. That's okay. That's okay. I'm not going to do that. And it's pretty cool that you could jump right in and open up your, if you have SolidWorks, it'll open up that SolidWorks part and you could jump in and start working with it, especially if you have HSM Works. You can go in and start to make this an assembly, make it work for you. Today we're going to do it in Inventor, so I'm going to close out of that part. This is the part we're going to be cutting today, making today. It's a SolidWorks part. We're going to import that into Inventor as well. But I didn't want to open it. What I want to do is just download the file. It's interesting. I downloaded it. I'm going to go into here. I'm going to say show in folder. So now I can see that file. It looks like I downloaded two. I'm just going to get rid of the extra one. And I'm going to take this file, and I have a folder on my desktop that I'm working with in my desktop called Webinar. This way I can put that file here. I'm just going to move it over so that we can work with it more directly, so we can find it quickly and easily. Okay, so I downloaded that file, and now I want to bring it into my Inventor. So I'm going to bring up Inventor. I suggest making a new project to work with that part. You can bring it into an existing project, but when you're working with something new like this, I often like to have it on its own project until I have it all solidified and worked out. And often I'll have different projects for different fixtures I normally work with. So I'm going to make a new project. So I'm going to go up to New, go into my projects. I'm going to make a new project. I'm going to call this one my Kurt, and I'll call it assembly or fixture. Okay, I'll call it a template too. My new Kurt fixture template, and it puts it into this default location, which is inside of my Inventor start. But I'm going to change that location, and I want that to be right in that webinar folder. Just for today, it's going to be on my desktop right in that webinar folder, so we can get to there easily. Okay, I can go to next. I'm not going to add any other projects to it. I'm going to finish it out. Now I have a new project that's added to my home screen here. So I'm in that project. As you can see, there's no folders, no files that have been created yet. But let's create one. Let's bring that Kurt Weiss into this this project. So I'm going to go to Open. Click Open. And while I'm here, I can see that I have a lot of different files that I can open. So we can open SolidWorks files, STEP files, SAT files, Pro Engineer files, Parasolids, IGES files, DWX, CATIA files, native, and a lot of different Autodesk file types as well. We're going to open up that SolidWorks model that we downloaded. This is the one right here. Open it, and it brings us to our CAD interface. This is CAD. We can open that as a reference model. So if we open it as a reference model, it'll reference back to the original SolidWorks file. If the original SolidWorks file gets updated, it'll update right inside of Inventor. In this case, I want to make an assembly template out of it, so I'm going to convert the bodies. So I'm going to convert it into single bodies inside of that part. I'm going to say OK, calculates, and now it brought that Kurt Weiss right inside of Inventor. Now these are just multi-bodies. There's no way to edit the body. They're just simple bodies that go in to make up this part. And then these are the bodies themselves where you can go in and push, pull, and make some live edits if you need to. What we're going to do is we're going to make them components. I want to be able to turn this into an assembly where I can slide that jaw in and out and drop a part in that represents what's going on in the machine. So the first thing I want to do is I want to change these over and make them all become components inside of this part, which becomes an assembly. And we'll make that assembly. So I'm going to go into my Manage tab inside of Inventor and say Make Components. Now here we have a function that says, where do you want to make the components? You want to insert them into an assembly? We're going to do that today. We're going to create an assembly. I'm going to call it Kurt D810. I'm going to call it Template. You can call it Machining Template, but this is the template we're going to use over and over to bring parts in that represent what's in the machine. Underneath it says, where do you want to save it? I can save it in the root webinar folder. I can also create a new folder here, and I can just say template. It'll create a new folder there when I hit the OK. So right now it says, what do you want to make? There's nothing in here. We didn't select any parts. We just simply started the interface. So what I generally do is I'll put a box around the entire assembly that I want to be able to make into, or the entire part, and it brings in all of those parts into the selection mode here. It's highlighting red because that place doesn't exist yet, but we're going to make it now as we move on to the next step. Okay, so I'm going to go to next. It says, oh, it's invalid. Oh, that's not good. Let's see what we can do. Let's leave it here. That's okay. We'll put it right in our webinar template. I might have typed something there. So here it brings in the solids. You can rename them here if you want. We don't really have to. I'm not really worried about what the names are at this point, but you can do that too if you want to name what's a jaw, what's a screw, and so forth. I'm going to leave them the way they are, and I'm just going to say OK. It takes all those parts, and it created this new template assembly. This new assembly right here. This is now components, and if you look, each one has an origin that we can now move those components around and do what we need to with them. They also have this thumbtack icon right here, which means they're pinned. They're actually fixed, or like we call it grounded in Inventor. They're actually grounded in place. Now you can go through and rearrange. You can move some of these things and put them where you want, but for this webinar, I'm going to leave them right where they are. Some of them. What I want to do is I want to unground those components we want to move around. So I'm going to walk through, and I know there's some components I worked with before, like this one, and I think there was a 3 and a 4. Okay, I'm going to grab those components. Let's see, component 13, if I remember correctly, and then I'm going to grab, there's 14, there's number 2. So I'm going to grab all these components that I normally would want to move around. I think I'm missing one there. There's the screw, and there should be another screw up here. There it is. That's the one right there. And there should be one more component, and I think it's the 15. Okay, so I got the 15, the 12. Nope, that's not right. The 13. This fixture, this one, number 4, number 3. I don't think I need number 2. And I think there's one more. That one. That one. Okay. So we're going to keep those components. I think there's the screw up here, this one right there. I want to add that one. So I could just select it off the view here. So I'm going to right click on top of those components. Okay, I'm going to go down to grounded, and I'm going to uncheck grounded. So now they're free to move around. I can actually grab a hold of those parts and move them around, but I can't grab a hold of anything that's fixed to move it around. I'm going to undo because I want all those components to be together because I'm going to make a sub-assembly out of them. The way we do that is if we highlight those components that are not grounded, I'm going to right-click on top of them, go down to Component, and then choose Demote. What that's going to do, it's going to move them into a sub-assembly that we can manipulate and move around inside of this assembly. So I click Demote. It's saying, what do you want to name that new component name that's going to be a sub-assembly? And I'm going to call this Kurt Moving Jaw. So it's easy for me to locate and know which parts I'm working with. It's going to save that as a sub-assembly inside of this folder right here. I'm going to say OK. It's telling me that when you're doing is restructuring it, you're going to move it around in the list, and it's going to be components that are no longer in the layout that we initially did. And that's OK. I'm going to say yes. And now we have a single sub-assembly that we can move around inside of the vise. And that's what I was looking to do. So now what we can do is we can align it. Now we want to add some constraints and some joints. So I'm just going to add some constraints real quick. Now, since we work from this body and it all had the same origin, the same planes, what we can do is use those planes to reassign back in so we can slide this thing right where it was. So I'm going to expand down on that subassembly and go into the origin. And now we have access to the planes that were originally used when it was made. The same thing on our main assembly. Okay, so now this has components and it's an assembly now. So I can say I want my YZ or XZ plane and the same XZ plane here, and I want those to be constrained together. So while I highlight those, I hold control to highlight those, go into constraint, and it snaps them together. It flipped them over only because that component was higher than the other, and it looks at it from the planar face. So all I have to do is just flip it over, and now it's aligned, and now I could just apply that alignment. And now it's back to the same alignment, planar alignment that it was originally. Now I want to get aligned along that center, so I'm going to use that center plane. This right here, this one is the XY in this case. Okay, and I'm going to hold control and hit the XY up here. I don't have to hold control because I'm in the place constraint, so I hit the XY and it knows to place those constraints. I hit apply, and I'm going to get out of here for now. You can fix it, excuse me, you can fix so that there's no longer any free movement in this direction. Now I don't normally like to fix it because I want that to move, so when I bring a part in, I can assign it and it'll lock into that new constraint. You can go a little bit further. I know a lot of people like to make joints and constraints that you can lock it down so it only goes to limit. This one will go right through. It just simply slides in those two planes, but you can lock it down even more. I've seen some people do some really neat stuff and make it like a screw alignment so the lead screw will actually work and move it in and out. But when I'm working, I like to keep it simple. I like to just place a part in here and be able to move it in and out. So there we go. We have our template assembly. We're going to use this to set up and mimic what's in our machine. And so let's get a part, bring it in, and start to set it up that way. So I'm going to save it. Make sure you save. It's going to say, do you want to save all those components that you created with the assembly? You're going to say yes to all and say OK, and it creates that full assembly with the sub-assembly, all the mates, and now I have a file in my webinar folder that now contains this assembly, which was made from the original SolidWorks part, which now I can close out. So that gives you an example of what you can do. Download from the internet a file, whether it's SolidWorks, IGES, SAT, even output from Inventor, and bring it into Inventor through any CAD, and you're able to make an assembly that you can use later. Okay, so the next step is I want to bring a part in and set it up that I'm going to machine it. So I'm also going to convert that part as well. I'm going to open up. I happen to have a part that's an intro to machining part that comes from SolidWorks. This is a SolidWorks part. I'm going to bring it in through any CAD, open it up. This time I'm going to reference that model. So I'm going to have a reference to the original model. I'm not going to change anything as far as the structure is concerned. I might add some features to it, but I want it to go back and reference that original model, so if the model changes, it'll update inside of Inventor. I'm going to say OK, calculates, and this is the part we're going to cut today. One thing I like to do, and this is a bit of a tip for you, sometimes what I like to do is on the part itself, I like to draw the stock model, the stock body I'm going to use to make this part. So while we're in here, you see that little blue arrow? It is still connected to the original SolidWorks part, and now features I add will be added on to that model. So as the model's changed in SolidWorks, it'll change and associative to the features I'm going to add on to it. So I'm going to create a sketch, and I'm going to create a box that represents my stock. So I'm going to go into my sketch mode here, and I'm going to go right into this plane right here, the XY plane. I'm going to create a sketch, right click. I'm going to go into new sketch. Okay, I'll look at it from the front. So I'm in the new sketch mode. And what I'm going to do is just simply create a rectangle around the part. Now this is going to be the basis for my shape, rectangular shape of my stock. Now I'd like to have it relative to the part. So if the part grows, the stock will grow as well. So what I'm going to do is I'm going to take this box and I'm going to give it a tangent relationship to my part, since these are all tangent around it. If you have a flat, you can make it also coincident as well. So I'm going to make this face, this part of the box, and this edge tangent, and it makes a tangent relationship. Same thing here for this one and this one, here and here, here and here. So now I have a box that's locked. You see it's no longer light or green. It's now blue and dark, which means it's now constrained. I'm going to highlight those lines. Actually, let's do this. I'm going to offset it so I can actually have my true stock shape. So I'm going to do an offset. I'm going to go into my offset up here. I'm going to offset that box, and we're going to add at least 1/8 of an inch around to represent what our stock body is going to look like. I don't want to use this. I'm going to extrude it, so I don't want to use these lines in the extrude. So I'm going to highlight those, and I'm going to turn those into construction lines. So now I have the basic shape of what my stock is. It's 1/8 of an inch around the part. So I'm going to finish that sketch, and I'm going to extrude a model that represents the stock around this part. So I'm going to go into my 3D model, extrude, and it recognized the sketch that I want to extrude on. And as I go up, I want that to be 0.45. So I want to leave 5 thousandths on top of the part. Now, right now, if I left it the way it is, it's going to actually think I want to put a big boss on top of the part. And I simply want to create a new body. So down here, I'm going to create new solid. And I want it to have on both sides asymmetric. And on the bottom, I want to extend that down 0.55. So I'm left with 1 inch of my stock, and I left 0.45 on top of the part. Okay, so I created a new body, and I made it an asymmetric so I can stretch it from the center plane, and I have enough stock covering that part. Okay, so I hit OK. Now I have this extruded boss. If you notice, in our history here, we have 2 solids. We have our original solid from our model, and now we have the solid that represents our stock. I'm going to highlight that body, that name. I'm going to call this stock. So now I have a stock body and I have a solid. Now I want to be able to use this stock body when I assemble it, so I want to be able to see through it. So another trick is to change the transparency of the stock body when you're here. So I'm going to right click on the stock body. Okay, I'm going to go down to properties, and in the properties I want that to be appearance as a clear blue. Okay, I can go down here and I can say clear blue. You can choose any color you want, but clear blue seems to work for me okay. And I click OK, and although it's just representing the stock body, I can see through it. When I go to place it in my assembly, I can see right through, and I know I'm placing the assembly on, or my constraints on the stock body itself. Okay, so we added an extruded boss. It's a standalone body, and we still have the association to the original model. So if the original model changes and grows, so will our extrusion, because we made it associative through tangency. Okay, I'm going to leave it the way it is. I'm going to save that part, go up to save. It says, what do you want to save it as? I'm going to call this one my intro to milling. Intro to milling part, save it. So now I have a part that I can use in my assembly here. Okay, I can close that out. Well, we can leave it for now. Actually, let me close it out. I'm going to insert it into this assembly, and we're going to constrain it inside of our jaws there. Now, you can model up and put parallels in here, because we know we're going to sit the model in parallels. For this webinar, I'm not going to do that right now. I'm just going to put the part and associate it in position. Okay, so we have our moving jaw. So let's insert that part. So in Assemble, I'm going to go to Place. I'm going to choose that new milling part, Intro to Milling part that we just created. Open, and it brings it into this graphics view. So right now it comes in normal to that Z which this was created on. Now later on we can look at another way to rotate the part around the assembly, but for right now we'll leave it the way it is as well. Insert that part. We can do multiple parts, but I'm going to hit Escape because I only want to bring in that one part. There's the part. There's the assembly. We're going to use constraints to now assemble that part. Okay, I can use the planes as well, if I want to constrain it by planes, but let's constrain it to faces. So I want this face and this face of my jaw to be constrained. So I'm going to go up to choose constraint. I'm going to choose this face of my stock, this face of the jaw, and it constrains them together. Okay, they're locked together. So I'm going to apply it and do another one. I want this bottom face and the top face of this jaw to be constrained, but now I want to be able to move it down a little bit so it's below that top face of the jaw. So I have this offset right here, and I can enter into the offset, let's say negative 0.1, like that. I can actually put 1/8 of an inch in, and leaves me a little bit of room. Okay, so you can add that constraint as you make it, the offset. I apply it. The last one I want to do is I want to move my other jaw into place, so I just simply select it in this face, and now I have representing almost there a constraint that locks them together. We're going to apply one more, and now let's say we're going to have from this face here to this face. Now sometimes you'll create a soft jaw and you'll be able to lock your place. That's really a good idea, to lock your part exactly where it needs to be. This way you can set your G54 up the same every time. But I'm just showing you how to work with the constraints. Because it sees these are both heading in the direction, I want to flip that constraint around. I'm going to hit this flush, and now I can add an offset, let's say 1.5. Actually, I want to do a negative 1.5. Moves it over closer to the center, and now I can find that corner right there and machine it. So we're pretty much set up there. I think it looks good. I'm going to apply, cancel out of here, and now we're able to insert the part into our template. Let me minimize this a little bit. So we inserted the part into the template, and now we're ready to be able to set it up for machining. Okay, so I don't really want to see that stock body, because when I do selection for my CNC toolpath, it'll grab that stock body, so I can just turn it off. So if I go into assembly view, change it to modeling view, and I expand down that part, now I can see all the models and bodies associated with that part. I'm going to go into the stock, right click, turn off visibility, and now we have the part in position. Our constraints are still there, but now we can machine that part. Okay, so let's switch over. Now we're moving into CAM mode. We have the part, we downloaded the assembly, brought it in here, was able to assemble it and match what's on the machine. And now I want to be able to cut the chips to make that part. So I'm going to switch over to our CAM mode. So when you're working with Inventor HSM, you'll have this CAM tab to work with. And the first thing we want to do is do setup to match what's in our machine. In my case, my template was set up initially. My original template was set up to be a turning part, so I'm going to change that to milling. Just to let you know, turning and milling, exactly the same workflow inside of Inventor HSM. So I'm going to do milling. It recognized the entire assembly as being what I want to cut. I'm just going to change that by hitting this X here and simply selecting the single part. Now, it put in a representation of what it thinks my stock should be. It looked at the minimum size that it could possibly be according to my part and put this temporary stock body in here, or stock representation. I want to use that stock body we generated. So I'm going to go into stock. I'm going to change this mode. Instead of relative size box, I'm going to change it to from solid. And now we don't really have a feature tree to be able to grab that solid on. Here is a tip. With your cursor inside the graphics view, hit alternate and S, and that'll switch you over to the modeling view inside of Inventor. Now I can expand down and select that stock body, and it now uses that stock body for my stock. I'm going to hit alternate A to bring me right back. My stock has been selected. I just simply hit, oh, I'm not going to hit OK, but my stock has been selected. I go back to my setup screen. Now I want to put that origin in the right direction, and I also want to put it on the corner of my stock. So what I'm going to do is I'm going to say model orientation. Now I can rotate around the X or rotate around the Y, but it looks like my Y and X are in the wrong direction because of the way this was set up. So what I'd like to do is I'm going to set my X and Y according to, let's say, these corners, these straight edges right up here. So I'm going to go into model orientation, select X and Y axis. So for my X-axis, I know it's running along this direction in my machine, so I just simply select a feature that runs along that direction. The same thing with the Y. The Y moves along this direction of the machine, so my Y-axis, I'm going to simply select geometry that goes along the Y. Now I was able to reorient the triad, and now I want to place it in the top corner of my stock right there. So I'm going to go to Model Origin, Stock Box Point, and I'm going to select that top corner of the stock box point, and now I'm ready to machine. My orientation now matches the way it is in the machine, and now I'm able to find that top corner if I probe, be able to work with that top corner. So that quick, we're able to get set up using the stock body that we created and reorienting my origin according to where I want it. I'm going to say OK. Now we're ready to start machining. The first thing I want to do is I'm going to trim off that 1/10 off the top of the part, or actually 50 thousandths we left on the top of the part. I want to show you some 3D toolpaths here. I want to work with some of the 3D toolpaths and show you how we can get this part done really efficiently. So the first thing I want to do is, traditionally I would do a 2D face, the face off the top, but I'm actually going to do a 3D adaptive. Okay, this workflow is always the same for every toolpath we work with in HSM. It's the same way in HSM Works. It's the same way in Fusion 360 CAM. It's always the same workflow, making it easy to learn and easy to use. So working from left to right, I'm going to select the tool. I'm doing a facing operation, so and I'm making this part out of aluminum, so I have an aluminum library. It's easy to create a library, and I suggest you do that. Create a library of the tools that match the way your machine is set up or what's in your tool crib. In this case, you can just right-click on My Libraries, create New Library, and you can start populating with tools. You could say New Mill Tool, New Mill Holder. In this case, I created one called Aluminum, and I started to populate it with aluminum tools. Now, HSM comes with a host of sample tools that you can work with. So you can bring up a sample tool and bring it in, and then just start to edit that tool to match. You just copy it in here and edit the tool to match what your tool is. You can also go down here and say New Mill Tool. It'll bring it into the tool interface, and you simply start defining the type of cutter it is. And then you can add dimensions that match your shoulder length, flute length, what makes sense to your tool. Okay, and you can also add a holder out of a standard holder library. We can also create holders. And you can go in to add your feeds and speeds that match what's in your catalog, your number of flutes, your cutting feed rate, and your speeds. And then start building your library that matches the tools in your tool crib. So I did that here with aluminum. So I'm going to use this 1 3/4 face mill. I'm going to select it, brings it into my graphics view so I can see what it's going to look like. Now I'm doing a 3D adaptive to face off the top of this part. So right now, if I chose OK, it's going to try to cut that whole part with a big old face mill, which would be kind of silly. So what I want to do is I just want to set it up for facing. I don't have to select any geometry because it's going to recognize off the model exactly where it needs to go. But in my heights, I want to limit it. I want to add some constraints where I don't want that face mill to go to the bottom of the part. I'd like for that face mill, I could drag it up to be on the top of the part. Now, I'm not going to drag it. I'll just simply do this. I'll go to Model Bottom. This is the bottom height. Should be the model top. Okay. It's recognizing our stock body there. So that's interesting. Actually, I'm going to set my top. My model top should be my stock top. Okay, my model top, I'm going to make this 0. Okay, so now I actually have it sitting right at the model top. 0 I'll set. That's because I dragged it up. And my top height is my stock top. So when it comes in, that's where it's going to start to feed from the stock top to cut off wherever it is in the model top. Okay, so that's how you set it up. Now our pass is, right now I have it defined as a fine step down and a maximum roughing step down from my defaults. So I right click and I look at the expression. This is just a bit of a tip and a trick, but this is the expression that's driving that maximum roughing step down. That's a good expression. I don't really need to change this for my defaults, but I do want to change this where I only want to step down, let's say 20 thousandths. So I get a couple step downs into the part. So I'm simply going to change that. It's not going to change the equation. I just overrode the equation for this toolpath. Okay, I'm not going to leave any stock because I want it to be nice and flush. I'm going to say OK. Calculates, and I have this adaptive clearing facing toolpath or face toolpath, which will step down nice and fine into the part. So let's take a look at it. So I'm going to go up to Simulate, Play, and I'm simulating it right on the model. I can see what it's going to look like right on the model for each step, each pass that it's going to take. So it keeps that tool engaged as much as possible as it takes off each of those on the passes there. So that's facing. It's going to face it down to the top of the model. Looks pretty good. I'm going to close that out. So I'm able to use a 3D adaptive to face off the top of the part. Now let's clear out some of the pockets in here. So I'm going to use a 3D adaptive clearing again. And now I'm not going to keep that same tool. This time I'm going to switch my tool over and I'm going to choose my 1/4 inch rougher. So I have a 1/4 inch roughing 3-flute end mill. Select it. I can see it in the graphics view. Now with the 3D toolpath, I don't have to select any geometry. So part of the difference when we're working here is 2D toolpaths, you have to select 2D geometry, lines, splines, arcs, and sometimes points to drive the toolpath. In this case, 3D milling, it's going to look at the surfaces, the faces, and the edges of the part to apply the toolpath. It's going to apply it in the most efficient way, keeping the tool, the radial edge of the tool, engaged with the material the entire time as much as possible, and you can control what that engagement is. So we're trying to use as much of the flute length to go deep and then keep a constant radial engagement, a constant load on the tool. So let's give that a try. Let's take a look. I'm going to say OK, leave everything else the way it is out of the box. It looks at the model. It looks at the step downs we can take. It looks at all those places where it can go efficiently to remove those chips off the model. So let's take a look at it. Looks like there's a lot of linking moves, but I think that's okay. So I'm going to highlight Setup, Simulate. Okay, we can limit some of those toolpaths by changing it to tail, so we don't have to see all that toolpath in the beginning there. I'm going to hit play. I think our model's looking quite festive here. We got the green and red for the holidays coming up. Okay, so I'm going to fast forward. We've already seen it through the face, so I'm going to go on to the next. Keeping that tool, as much of that flute length as possible, helix is in. As you see it helix down, we're leaving room with a taper, and as it reaches the bottom, it works its way out, keeping a constant load on the tool. It's the same size chip as it works its way out. You're able to control that same size chip. You can run at higher spindle speeds. Controlling that friction and being able to control that load on the tool, you can run at higher feeds and speeds and get your part off the machine a lot quicker. So you can adjust and control that radial engagement, how much load is on the tool, and it's so much better than traditional tool paths where you can get into a pocket like that. Here it keeps the same size chip, the same bite going in all the way into the pocket. Traditional tool paths will try to get into that corner and really use a lot more of that tool than it can handle. And you'll end up with a large section or let's say 70-80% engagement, and you're going to hear it in the tool, you'll hear it in the material, and you'll eventually wear out your tool a lot quicker. So you're going to save your tool life using adaptive. You're going to be able to run at higher feeds and speeds, get the parts off a lot quicker, okay? And you're going to save yourself from any breakage in the corner because it's going to keep that same chip load. It doesn't bury itself in any of those corners. Really efficient way to remove a lot of material. So here it's getting in those little corners of stock. I might want to adjust my stock size a little bit to make sure I have enough room around it that it cleans up. But here it's finding all those places efficiently where it can go, even on prismatic parts like this, to be able to clean up and give you a nice rough on that part. And all I did was select the tool. Let me close out. I'd like to clean up those places where I left stock. I think if I look at this, if I go to edit that adaptive, you can see in the passes tab, this is the optimal load. Here's how much is engaged. I'm going to go to edit expression, or you can hit F2. It's driven by an expression, the tool diameter of the tool that we brought in, the 1/4 inch tool, multiplied by a factor. In this case, 35% of engagement. You could change this factor, you can make it like 40%. Okay, it'll recalculate and give us our new step, or shall I say, our new optimal load. That's our new engagement. So you can control every one of these aspects. You can control how much of that radial engagement is in the material. Down here, we also have stock to leave. We left 20 thousandths. So I want to come back and clean up that 20 thousandths. And I'm going to use a couple different tool paths. Okay, I'm going to say OK. I'm going to come back with a horizontal. It's recalculating now to give us our new optimal load. I'm going to use a horizontal toolpath, 3D horizontal. Really nice toolpath to clean up all those flat faces. It finds its own containment. So in other words, it's going to look at all those places where that tool can go efficiently to clean up all the flat faces of the part. Okay, again, I'm going to keep the same tool. If I want to clean it up, I'm going to use my 5-flute finishing tool. So I'm going to go back into my aluminum library, get my 1/4 inch finishing tool, select it. Okay, I'm going to say OK, and it's going to find all those places where it can clean up on the faces of the part most efficiently. Now we've already faced this off. It sees that as a horizontal face. So one trick to keep it from trying to redo that top face, if I go to horizontal, edit, in my heights, it's looking for stock top and model bottom. But my top height doesn't have to be stock top because we did a facing to clear that off. So what I can do is I can change this to model top, and I'm going to go -0.001. So it's only going to look at, so it's going to contain anything that's below that thousandths of an inch below the top face of the part. And I say OK, recalculates, and it knows we don't want to do that top face now. So now it's going to look in those pockets where we can remove that material most efficiently. We'll do the same thing with the 2D or 3D contour. I'll go up to do a 3D contour to look at where we left stock on the walls and clean all that up. Again, I'm going to keep my finishing end mill. I'm just going to say OK. Leave everything else the way it is. It'll go and take a look at the model and all those places where it can go efficiently. I have a very fine step down on here. We could change that as well, but it's going to look at all those places where it can it finds those vertical walls to clean up really efficiently. If I right click, go to edit, I can see my passes, and I do have a maximum step down of 10 thousandths of an inch. I can simply make that a little bit finer. Let's say 1/8 of an inch we want to step down. Calculates quickly, and you can see we changed that step down to 1/8 of an inch. You have control over how much you want to step down in the material and your step over. You can also come back and do multiple finishing passes. Okay, so we're able to get that contour. Let's drill some holes and get some code in the machine. So I'm just going to do some basic, real quick drills. I just want to get some through holes just to test it and see how it looks in the machine. So I'm going to go up to drill. Now I forget what the hole sizes are. So if I hover over that hole size, you see down here in the corner, right down here, it shows us the diameter of any hole we hover over. And that looks like it's a number 36 drill. We're probably going to do some 36 or some tapping in here. So I'm going to go and get a 36 drill. Okay, so I'm going to select in my aluminum. I think I have a 36 drill down here. Okay, we're going to do a 632 tap on this, but right now we're just going to select the pre-drill. Brings the drill in, and in my geometry I'm going to select that hole shaft. And if you think you have 100 holes on a part, you got to go through, and I'm like, that's really tedious to try to grab all those holes. You can also use a function here, select the same diameter, and it grabs all the same diameter in the same plane. Saves you a ton of time trying to find holes when you're working with it. Okay, we have our heights. I want to make sure I drill all the way through the bottom of the part, so we can choose drill tip through bottom, and we'll give it an offset 50 thousandths will work. For our cycles, we have a lot of cycles that work well on the Haas machines. Deep drilling, chip breaking, tapping cycles. We're going to leave it as regular drilling for now. I'm going to say OK. So now we have these tool paths to be able to rough this part out in the machine. So let's get some code over to the machine now. So we're running the Haas VF. So let's get that code out. So I'm going to highlight setup 1. Okay, I'm going to go up and to make a setup sheet real quick. Where do I want to save it? I'll save it right there is okay. And it gives us this HTML setup sheet out of the box. Really good setup sheet. If we set up our template correctly, we could just plug those numbers in as our WCS right in the top corner of the part. Our totals, which tools are we using? Okay, what's our maximum spindle speed, maximum feed rate? What's the estimated cycle time that it's going to take? You could do a lot of your quoting right from here. Each setup, each operation is set up with what tool, what holders are being used, our diameter, our length offset that you can plug right into your offsets. Okay, the estimated cycle time for each of these operations, the cutting distance, feed rates. So you have all that information here in one setup sheet. Really nice setup sheet right out of the box. Now, let's get that code to the machine. So I'm going to highlight setup, which selects all the toolpaths underneath. Let's go ahead and post out. So I'll go to post process. We're going to post on my generic Haas, works well for the VF machines. We have lots of switches we can turn on. If you want to allow helical moves, if you want to take a look at optional stops in there, preload the next tool in your carousel. If you want to, let's say G28, G187, turn on the high feed. So you have all these different switches you can use. I'm going to say post. I'm going to overwrite that 1001 I did earlier. And now we have code that we can run right in the machine right now. So I just realized something though. Our part is not the right part. I have to go back and make some changes because I just realized if I run this, it's not going to be the right thing because I need this linkage to be 4 holes per side, and it has to be a little bit longer of a part. Okay, so let's go back and change our model. Now, since I imported this model originally from a SolidWorks part, what I could do is I can edit it. Let me go back into my CAM. I can edit that part in SolidWorks. In fact, let me open it up. There's the part in SolidWorks. We opened this up earlier. As a matter of fact, I think I might have a different part that I used. So let me just double check. I'm going to go to Open. There's our webinar. There it is. Intro to 2D Machining. There's our part. That's the original part. So now I'm going to change this part. So my circular pattern, instead of having 3, I'm going to make it the 4-hole configuration. And I'm going to stretch the part a little bit. Instead of 1.25, I'm going to make this 1.40. So I stretched it out in SolidWorks, changed the shape of the pockets, changed the number of holes. I'm going to save it, update it, and save it. That's my SolidWorks model. So I'm going to minimize, and notice we still have the 3-hole configuration, but up here we have this icon that says there's a local update. Something has changed in one of the parts. If I click that update, you'll see it update the part that was in SolidWorks. Looks like it's stretched outside of my definition for the the stock. I'm going to have to go and do a setup or an update on that one. But you can see it's still trying to do the face. It's still trying to get that 3-hole configuration. So if I go to setup, I'm going to go into generate, where I can right click and generate. I'm just going to click generate right up here. Recalculates all those toolpaths, updates the stock, you see. And now we have our toolpath doing the 4-hole configuration. Our drills are in the right location. There's 4 of them now on each link, on each side of the link. So we're able to update directly right from that SolidWorks part, and all of our toolpaths were integrated completely. So now if we go to setup, I'm going to go to post process, I'm going to post out, save it, we're going to overwrite what we did before. Yes. Now we have the new model. Now, I didn't see too many of these dimensions update. So what I want to do is I want to verify the lines of code. So if I go up to backplot, I'm going to choose the backplot window. And now I can see in the backplot window what it's going to do line for line in the code. There's our face operation. And I can see it's doing the 4-hole configuration. It looks like it's the right part. And if I see that tool go into the middle of nowhere, I know there's something wrong. I need to go back and check my program. But so far it looks pretty good. I like how that looks. All right, so I'm pretty safe. I'm going to send that part over. So I'm going to close out my backplot window, go up to the top of the code just to check it, and then I'll save this on my thumb drive, bring it over to the HOS machine, and we're good to go. Okay, so we're able to update. We're able to add 3D toolpaths. The part will change. If we do change the part, it updates automatically. It integrates into each of the toolpaths, get updated automatically. If I want to change anything, if I go to the adaptive, it's always the same workflow, easy to find. Heights are color coordinated, easy to work with. Linking parameters, this is how we approach and move away from the part. And if we look at that in every one of our toolpaths, if we look at a horizontal, exactly the same workflow. Our passes we're able to change as the tools engage the material. Linking, we're able to change the way it approaches and moves away from the part. So it's always the same workflow. And anytime we make a change, we can always see it update right in the graphics view, and we know that our part, as our part changes, it updates inside of Inventor HSM. So with that, let me bring this up real quick. I think I did here it is, my PowerPoint. I just want to make sure we covered everything in our webinar today. But we were able to walk through. I showed you we could download. I went right to the Google website. Let me bring this up. So we downloaded a part. We downloaded a part from our Google website, which is our vise, our curtain vise. We converted it. We were able to bring it in through AnyCAD. We created an assembly out of it with components. We're able to bring in our part and assemble it. I even showed you how to create a stock around the part. And for our CAM, we're able to go in and apply. We mainly applied 3D toolpaths to the part to get it programmed really quickly and efficiently. We're able to output code to our machine and even verify that code. Made a change right in SolidWorks and update it right inside of Inventor. So it's easy to use in our complete integration. So I think we covered a lot that we had set out to today. And please, if you have any questions, you can please feel free to ask any questions in our question box. If I don't have an answer, I'll get one for you. It looks like we just have a few more minutes to go through, and I could talk about some more information as to help you get started. Let me bring up my browser here. We do have our forums. We do have places where, let me show you our forum real quick. Our main forum is our CAD, or shall I say, our HSM forum. So when you're working with our interface for HSM and HSM Works, we also have the forum for Fusion as well. But you can get help with post-processors. We have our Autodesk technical elites, our teams who look at these posts every day. And let's see, we have a question. Do we have some time to show a rotary wrap using 4th axis? I can do that in in this webinar, I don't know if I have enough time, but we can walk through. I think we do have a webinar coming up very soon where we're going to do that rotary wrap. Drill a hole pattern in a pipe. Oh, gotcha. Okay. So we can show you that. We have a webinar coming up shortly after the holiday. In fact, that first week we'll have a webinar that we can walk through the new wrap toolpath and how to index. And you can actually do those drilling holes. You can index around the pipe. Today you could do that. But I will walk through. We'll make sure we make that in a webinar, Roger, to make sure we can show you how those wrap toolpaths work and how to index around a cylindrical part to get your parts done. Okay, and we actually do, you can take a look here, Roger. There is, if we look up YouTube, let me look up YouTube, and this gentleman here, Mike, if I could spell his name right, this guy right here, Mike Matern. That's not the right guy. Sorry, guys. Let's do it this way. Let me go and I'm going to look up. And in fact, if you do a Google search in our YouTube channel, and I'm going to look up Autodesk and fourth axis wrap. This right here, Fusion, well, it's in Fusion, but it works the same way in Inventor. So if you look this up, Fusion Rotary Wrap, Mike Matera, I spelled his name wrong, but Mike Matera did a great job putting together some videos on how that works. How to work with the fourth axis wrap. There's no drilling here, but you can work with getting your drill pattern, and then you can pattern it around that up here in the pattern, and pattern it around and get the rotary toolpath that you're looking for. But here's a great place to start to look at some of that fourth axis. We're going to do this in Inventor as well in a future webinar, but I just want to let you know you can go here and do a search for some of the videos that Mike Matera made. Really good, helpful place to go to see what's new with rotary wrap and multi-axis toolpaths as well. Okay, so we'll do that in a future webinar. Also, to take a look, you can also get help here. If you do a search in our HSM forum, you can also look in the, like I said, the Fusion forum, but this is where our technical elite as well as developers go to look. So if you have questions about how to do that, or if you're looking for a video or help or tutorials, you can go here and they'll point you in the right direction. You can always go to our main site. If you go to cam.autodesk.com, this is a great launching place. Get started right here. You can see we have events. You can always see where our webinars are going to be. We have tips and tricks in here that you can find, and we have our learning channel, as well as you can link to our forums right here. But if you go into learning, a great place to start working with Inventor, HSM, or HSM Works, or even Fusion. And these will take you step-by-step tutorials on how to get working with 2D, 3D, 5-axis, multi-axis milling and turning. So a great place to start, our CNC handbook and our CAM forum as well. And you can link to that CNC handbook. So if you're new to working with CNC and milling and turning, this is a great place to start to get a background and learn about how those tools work, to learn about safety, to be able to go in and look at your different languages, CNC programming languages, and working definitely with support for Haas in here as well. CNC operation. So these are some of the guidelines the team uses at Pier 9. Pier 9 is our facility in San Francisco, right on the bay. So we've created an awesome workspace where we invite a lot of people to come and work and learn about CNC and 3D printing and laser, as well as a lot of other aspects of being able to make things. So it's a great place to go if you have a chance to ever visit at Pier 9 at San Francisco. So here's a great resource that you can use to walk through. This is our CNC handbook to get started. So we have our forums you can reach. Go to our main site and you'll be able to link to a lot of these resources. Okay, and then of course we have Autodesk Education. So if you look up Autodesk Education, You'll see all this software is free for all students to download and work with, including Fusion 360 and our HSM, Inventor HSM Pro you can download and start working. So our education community, a very strong community, finding where we work with HTechs, we work with the software. You're able to download it into your school and be able to start working with it for free. So our engineering and machining education sites are really a great place to start. So I just want to let you know you can get all these software for free through Autodesk. All right, so with that, hopefully that was helpful. Hopefully I was able to get you started. We walked through downloading using any CAD, brought it into a model, started working it, created assembly from that model, being able to create a template where we can bring a part in, and then setting it up and getting toolpaths. Sending it out to the machine, doing some updates. You can do it really quickly, get started really quickly with working with your machine. Stay safe with it, and follow those guidelines for CNC, safely CNC machining, and you'll be rolling right away. So with that, guys, like I said, we'll do some future webinars. We have a lot of great stuff coming up. In fact, in January, we're going to have Carl Bass is going to join us, and he's going to walk through with us some of the projects that he's done in his personal shop, and it's really exciting. So that'll be the 20th, and on the 13th, we're going to have Jeff JJ. He's going to work with us to show us how to get some really nice surface finishes on parts using HSM. And I think that first week of January, Roger, to answer your question, is where we're going to jump into some of that 4th axis and 5th axis toolpath. So that'll be the first week, the first Friday of January. Okay, guys, with that, thanks for joining us. Again, hopefully it was really helpful for you getting started. Have a great week, and or shall I say, have a great couple of weeks, and enjoy your holiday, relax, spend time with family, and we'll see you back in January to multi-axis stuff. Okay, guys, take care now.